and today we're going to be looking at recursion. So I'm going to give you some examples on recursion. We're going to talk about what it is, and you can code along on my text editor, and we have DevTools to also look at what's going on. So I've attached the index in an HTML file. So basically, recursion is a function that calls itself in JavaScript. So let's create some pseudocode. So if I have a function called recursion, inside of it, we call recursion. And if we execute recursion afterwards, what do you think is going to happen? I'll let you think about it for a second. So basically, in our function here of recursion, we call recursion, and then that executes recursion. Well, first we actually execute recursion. By executing our recursion function, we run our function script, which executes our function recursion. When we execute this recursion, we create a call stack, because then we run our function recursion again, which creates another recursion execution, and so on and so forth until we get this infinite call stack of the function's recursions happening. However, this is never resolved since we have no other conditions for it. So what we can do then in our recursion function is create a base case. And you will often see base case, you'll see base case in a recursion function. So the base case, you'll always see this. So the base case essentially is the conditions that we're setting up for our recursion to be looping, because our recursion in computer languages is something that is reoccurring, right? It's the recursion process of something that is happening. And we are using the inherent call stack of recursion. So, for example, if we set up a base case condition, we would say something with a conditional operator. We could say that if, let's say we had a number as our argument. We said n is less than or equal to 0, return 0, else we will execute recursion. So n then is our argument, so we will create in our function argument of n, and then we call the recursion of n. So if now we execute recursion, what do you think is going to happen? Let's say in our recursion, well, first if we execute it without a number, it'll say, we need to pass an argument. So let's say we give it 4. So we execute recursion 4. Our function gets run if n is less or equal to 4. So if 4 is less than or equal to 0, so 4 is greater than 0, so we pass this condition, we don't return 0, we go to our else, and we run recursion again with our n argument of 4. 4 gets passed in for our recursion, we run the recursion again, 4 again is greater than 0, we pass this, again we run into this infinite loop. Okay, so now we're seeing recursion with a base case. We're seeing a recursive function with a base case and recursion, however, it's still stuck in a loop. This is just to demonstrate to you the process of recursion. So if you are starting to see it a little bit better than you did before, then that's really great. If you're still not sure and this doesn't make that much sense, that's okay. It's just a little bit of pseudocode just to get things going, and we could start looking at some real examples. The other thing to bear in mind right before we begin is that whenever we'll see a recursive solution, there will be an equivalent iterative solution. So why is that? Well, basically because when we have an iterative solution, we're creating our own call stack, right, of what we want to do and iterate. So then why not always just use iterative solutions? Why are recursion solutions so powerful? Well, for one thing, think of it in terms as though it's going to be less code, right, than if we're having these complex algorithms and we're writing out all of our loops. Instead, we can just call our function, and so less code means less bugs, and also means that we are using the call stack of our function as opposed to creating additional call stacks, which is also better. So there you can see that already that there's a few benefits that are that we can gain through recursion. Why this is such a valuable and powerful advanced tool in JavaScript. Great. So now that we've talked about that, why don't we go ahead and write out our first iterative solution before we move on to our recursive solution. And all right, let's go. And we're going to start with factorial sum. So we're going to make a function that finds the factorial sum of a number. And what is a factorial sum? Well, factorial sum would be n squared. Oh, where's my squared? We've got n squared plus n over divided by 2. Okay, so actually have n squared plus n over 2. So we have here, we can see it in some other sigma notation, if you want to look at it in sigma notation from other mathematics. But we don't have to get so complicated. We're going to find the factorial sum of a number with a for loop. So to do that, we'll create a function. And if you don't know what that means, or if you're looking at that equation, just look at the equation for now. And if that still doesn't make sense, we're going to look at the solution, and I'll explain the loop as how the loop works, so that you can better understand it. So function factorial sum, we'll take the argument n, which is a number that we pass into our function. Okay, and inside here we can create a variable. So we're going to use ES6 let total. Okay, and we're going to set it to the numerical value 0. And now we can run a for loop. So we can say for let I equals 0. Let I equals 0, I to be less than n, and I plus plus. So if you've never seen a for loop before, or you just want to review it, we can do that quickly. So for loop has 3 conditions. So it's a loop. For is a very standard common loop that we use in JavaScript. And this syntax is also it's widely used. So we have our 3 conditions here. We're setting up our index, i's for our index of our loop, and we're setting it to 0. Okay. Then our second condition is we're saying that our index should be run the loop until I is less than n. So we're saying I is less than n is our number, right? So, and then so let's say our number is 4, and we're starting at 0. We're going to keep iterating through. We're going to continue to iterate through whatever it is our function needs to, and n until we reach that n, which would be our 4. And then our third condition is what we apply to I, and plus plus here is going to be adding 1 to I every time we loop through. Okay, so now we can add a code block over here beneath that, and we can say our total can plus equals short syntax for total plus total equals, right? So total plus equals I, and we can return our total. All right, and so I'm going to console.log. We're going to create a log so we can see the result. And what do we need to do now to get this loop to work? I'll let you write that. So that's great. So if you wrote factorial sum and you call it, right? And we need to set it to a number. So why don't we set it to 5? Okay, now let's save and go into our DevTools and refresh. And we get an error that says factorial sum is not defined. That's because we need to be careful about our capital S over here. Let's do it again. Refresh. Okay, and we see we get 10. Okay, so why do we get 10? Well, let's go back to our calculation over here, our formula of our sigma for factorial sum. So we have n squared plus n over 2, right? So if I take out a calculator, and we can run this calculation manually, like in the olden days. What was it again? It was 5? Is that what I used? Yeah, I used 5. Okay, so what did I do with my calculator? Okay, so we would say 5 times 5 plus 5 divided by 2, and the answer is 15, okay? But we are getting 10. So why are we getting 10 when our factorial sum should be 15? Well, I'll let you think about that for a second. And I want you to take a look at the for loop in particularly. Well, if you notice, it said for let I equal 0, I less than n. If n is 5, then we're running up until which is 5. So we're only actually running it not to 5, but up until 4. But if we set I is less than or equal to n, and we refresh, we see 15. Now, if that makes sense to you, that's awesome. That means that you understand the iterative solution for finding a factorial sum. However, if that doesn't make sense, that's fine too. If not, we're going to look at the recursive solution and see how we can create the same results recursively of our own call stack versus the factorial iterative solution. And if this does make sense to you, then that's great, and we can move forward. So I'm going to leave this up here for now. We're going to create another function. We're going to call it factorial sum recursive, which will also take an n. So remember, we need a base case first. So I'm going to stop and let you think about what the base case should be. Well, remember, it should be a condition, right? So if n is less than or equal to 0, the number, right? The number of our argument is less than or equal to 0, we can return 0, right? Else, and what do we do here? Well, we can return our number, okay, whatever the number is. We're going to say it's going to be 5 again. Return our number, and we're going to add it to our factorial sum recursive. So we're going to call, oops, that's not right. Factorial sum recursive, so we're going to call our function, okay, n minus 1. Okay, so what is happening here? I can see how this could also look quite confusing. So why don't we look at this? So we have n, which is our number, and we have our base case condition, and then we have our our recursive execution over here. So what we are saying is that, let's say here, if we console.log factorial sum recursive, and we run it to n, and then let's just add a string so we're not so confused as to what's going on. And we can just say recursive factorial solution, okay? And we can also go here and we can say, just take a comma, and then over here we can just say our iterative factorial solution, okay? So why don't we save this and just take a look at what's happening here. Refresh. N is not defined. I'm getting an error that n is not defined. Okay, because I put the argument n when I should be actually writing in our number. So 5, we're going to use the same number, 5, and refresh. And now we see in our log here that we get the iterative factorial solution in 15 and the recursive factorial solution in 15. So we're getting the same results, which is good. So how is this working? How is our iterative solution working? Well, we're basically, in our call stack, we're winding up our functions, and then we're unwinding them. And what does that mean? Well, if we see in our factorial sum recursive of n, we're seeing n is less than or equal to 0, then we return n. So why don't we go through this step by step? If it's 5, right, so we set the number of n to 5. Is n less than or equal to 5? Is 5 less than or equal to 0? No, it's greater than 0. So we don't return 0, we move on to our recursive execution. And what are we doing to our recursive execution? Well, we're adding the number 5. So we're adding our number, which is 5, plus our factorial recursive, n minus 1, which would be 4, right? And then we're calling it again. Okay, so we get our number in like that, and then that gets added to 4, and then that happens again. We call the factorial sum recursive. It goes back. Now n is 4. Is 4 less than, if 4 is less than or equal to 0, which it's not. It's greater than 0, so we move on. We do the same thing. It becomes 3. Same thing with 2, 1, until we hit 0. Yes, it is. Then we return 0. So each time we're doing this, we are building up our call stack. And then once we hit 0, we add up all of the numbers. We return, and that's called unwinding. And we unwind all of our functions because we're creating these nested functions, essentially, that build up until we return our function, and then we unwind our functions. So if the winding and unwinding doesn't make that much sense yet, that's totally fine, because we're going to look, now that we've taken a look at these basic factorial sum functions, we can start looking at 2 more examples that are going to be using arrays that will be a little bit more complex, but not too bad, and they will demonstrate, I think, in a even more clearly how the call stack winds and unwinds, and hopefully this will help you understand more with recursion and how these functions work. So let's go ahead and write out another iterative function. So what we're going to do now is let's say we want to write a function that's going to create an array of the amount of the, it'll create an array of 0 to n, and we will do that with a function that will take that argument of n. Okay, so we can just say function, and we can do this in incrementally. So we can say function increment array. Let's say take n. Okay, and this is our iterative solution to this, right? So what do we need to do this then? So why don't we make a constant array, we set it to an array, and we're going to use another for loop. So for let I equal 0, I should be less than or equal to n, once again, I++, okay? Then inside of here, inside of our code block for a for loop, we can say array.push, and what do we want to push? And what is push, by the way? If you're not familiar with push, well, that's a JavaScript method which is going to add, it basically adds to an array our elements that we are adding on. So we want to be adding right now the elements of our loop. So in this case, what would that be? It would be I, right? And so we would be pushing this onto, we're pushing our I into our array, which is an empty array. So we're getting our values of whatever the numbers are up until the point that the number is called, and then we return array. So if we console.log our increment array, and we give it 5, let's save and see what happens. Go to our DevTools and refresh. Okay, so now you see that we have, beneath our iterative recursive, we see that we have an array that has 6 elements with our numbers 0 through 5. Okay, so 0, 1, 2, 3, 4, 5. All right, so our iterative solution is now getting 0 up to n and creating our array. It is working. And if that makes sense, awesome. If not, just quickly looking through it again. So what we do is we set it up to 5 in our loop, right? So our argument is set to 5. Our array is an empty array. We say that our index from out of our 5 is going to be 0, so we're saying 0. Since 0 is less than or equal to 5, we add another one. We push that into our array, and then we continue the for loop up until we hit our 5, and that's how we get our new array with our 0 to 5. Great, so this is the iterative solution to increment an array that goes from 0 to n. Okay, so what would be the recursive solution? And we can actually say, why don't we go ahead and write a string? So I'm just going to copy the string here and write, oops, excuse me, so So this is the iterative array increment solution. Okay. So now why don't we go ahead and we look at the recursive solution. So function, write out another function, increment array recursive. Okay. So we're going to give it the argument of n once again. Okay, and so we need a base case. So we can say if n less than or equal to 0, just like last time. Okay. Return, and what do we want to return? Well, in this case, since it's an array, instead of returning 0, we can just return an empty array, right? And then in our else, we can have our else over here. And in our else statement now, we can actually, now that we have our base case, we can execute our recursion, right? So we can do increment array recursive n minus 1, okay? And what we can do here actually is we can create a new variable, and we can say this could be constant, let's say r for our array is our increment recursive n minus 1, and then we can do r dot push n, and we can return our array. Okay, and let's go ahead and console.log our recursive solution and take a look at what's happening. And I'm just pasting over here the iterative array increment solution, and I'm going to rename this to the recursive array increment solution. We can save here, and we also have to remember that we are calling our function increment array recursive, not increment array, so this should be renamed to increment array recursive. So let's refresh. Okay, so our recursive array increment solution is beneath our iterative one here, and we can see back in our dev tools that we're getting 1 through 5, where as opposed to in our iterative array, we are getting 0 to 5. So it is working, but it's not working the exact same. Why is that? All right, well, we are stopping here at 0, right? And we're doing n minus 1. So if I remove the equal sign and I refresh our solution, we are actually grabbing our 0. But before, when we had equal to 0, we refresh, we weren't starting at 0, right? So that's why we're missing in our array, in our recursive solution array, that extra element is because our array is not, our if condition is not working the same way as our I. We're not checking an index in our for loop in our increment array versus the number. Here we're setting our base case condition of the number until it reaches 0. Now, there's a little bit of a counterintuitive caveat here in terms of when you first look at recursion and the call stack and winding and unwinding, and this is why I wanted to build it up like this, because let's take another look here. I'm going to remove the equal sign again, and I'm just going to push this back to how we had it before. Okay, so how is it, let me ask you this, how is it that in our recursion, if we're doing n minus 1 and we're losing 1 each time and we're starting at 5, how come our array doesn't go 5, 4, 3, 2, 1, and 0 instead of 0, 1, 2, 3, 4, and 5, right? How come we're incrementing instead of decrementing when we are subtracting n minus 1 and we are starting at 5, and yet we're returning starting at 0? Well, this is to help understand exactly how the call stack is winding and unwinding, as we mentioned earlier. So what that means is when we are starting, we are actually starting at 5. We are indeed actually starting at 5 and going 5, 4, 3, 2, 1, 0 until we hit 0, and then we're stopping. But that's not when we return. our function, right? Then we return array. What we've actually done, and this is why I wanted to start with factorial sums, because it's similar in the sense that we are creating these nested functions, these nested recursive functions on top of each other, and they're winding up until the point that our base case condition is met. Once that happens and it's satisfied, we return our function and we unwind all of these functions that we created. So then our 5, instead of starting at our 5, we're returning them in the opposite order. So our functions are now being returned. Starting at 0, then 1, then 2, then 3, then 4, then 5. Now, to further illustrate this point, well, or as an exercise, before I do this, how about you guys can figure this out? How would I change this function that's an increment array recursive solution and turn it into a recursive solution that will actually decrement? So I want to start at 5 and go 5, 4, 3, 2, 1, 0. How do we do that? So you can pause the video here and you can try that out, and then unpause when you're done, and I'll have another sip of coffee. Okay, well, another method that we can leverage here is unshift. So if I set my array over here, which in this sense is actually running our recursive execution, n-1, and I refresh, unshift is now going to take the reverse and take our last element and push it to the first, and that's why we are now having a decrement solution over here. So what we could do is, I'll just why don't I just rename the function to decrement array recursive, and remember to call it, and we can go ahead. So if you figured that out on your own, then congratulations, you now have a basic understanding of recursion. And if you didn't figure it out, that's fine. If you didn't figure it out because you weren't sure how to flip the numbers, but you still understood how this was working, then that's really great too. And we're going to take a look at one more example now before concluding this video to hopefully help even further understand recursion. And if you didn't understand anything at all, that's totally fine. Recursion, if it's the first time you're learning about this in computer languages, then it's definitely something where you need to familiarize yourself with the call stack and how we can actually build up these iterative solutions and bring them down, simplify our code, and create just more of efficient processes in our writing. So to look at one final example, one more time, we're going to do the same thing again. We're going to create an iterative solution, and then we're going to look at the recursive version of the iterative solution. Okay. So in this last situation, we want to make a function that's going to be an inclusive array param. Okay. And so we want to create basically a function that takes two values. It's going to take a starting value and an end value, and then through those two values it will produce an array that goes from the start value to the end value, through whatever that number is to the end number. So we're going to create a function inclusive array param, and we're going to say start val and end val. Okay. And so in order to do this, what we can do is, once again, we can write another for loop. So we can say for let I equals 0. Is this right? I equals less than, where do we want to loop until? I should be looping until the end value, right? And I plus plus. Now, there's one mistake in this for loop that I just wrote out. Can you spot it and correct it? You go ahead and pause the video and try to figure that out. If you can do that. Okay. Well, if you thought, well, wait a minute. You said that we're basically creating this inclusive array parameter setup with a start value and out value. So if we say let I start at 0, then shouldn't we actually have our I be starting at our start value if we're making this loop? And yes, that would be correct. So I, instead of setting it to 0, it should, let's start it at the start value and then end at the end value. If you didn't see that yet, that's fine because we haven't actually written out all the code. So if you did spot that, you're definitely following along, which is great. So now we have our start value and our end value. And what we want to do here is basically we want to create an array, just like we did last time. So above our for loop, we can say constant array, set it to an empty array. And here inside our loop, we can just say array dot push. And what do we want to push into the array? I'm going to push I. And finally, what do we need to do? We're going to return the array. All right, well, let's console.log quotations, and let's write the iterative inclusive array solution. And what do we need to do finally is call our function, inclusive array param, and we just call it. All right, let's save that and check our DevTools. And so we get an empty array. So why do we get an empty array? Well, this is because we're saying let I equals 0, increments to the start value, right up push I, and then we're returning our array afterwards. This is not working because, oh, flip this here. And, oh, well, also, we have to remember to create a start value and end value in our arguments, right? So let's say we're going to create a start value at 2 and an end value at 6. Go back into our DevTools. And now we're going to see in our iterative inclusive array solution, we have 4 incrementing. So we have 2, 3, 4, and 5. Okay. So our 2 is our start value and 6 is our end value. We're starting at the start value, which is 2, and then we're not ending at 6 because remember we're supposed to end at we're saying when I is when I is less than the end value. That's when we end. So if we set it to less than or equal to and we refresh, we're going to include 6 as well. Okay, so this is our iterative inclusive array solution, and essentially it's very similar to our incrementing of the array, right? If you're looking at this, the only real difference here is that we are, instead of just looping through what the one number is and then pushing that number, we have 2 arguments and we are pushing into our array our index based on the start and the end. And that's simply it. That's really the only big difference here. So it's not too bad, really, right? So why don't we go ahead and look at the final recursive solution for this. So create a function. We're going to call it inclusive array parameter recursion. Recursive. That's fine. And we're going to give it a start value and an end value. So what do we do first? Like we did in our previous examples, recursive examples, we always have a base case, right? So what's our base case? Well, what we want to say is that we want to say that if our start value is greater than or equal to our end value, then we want to return the function. Otherwise, run the condition. Otherwise, execute our recursive function, right? So how would we write that? We can say if the start value is greater than or equal to the end value, we can return, why don't we return an array with our start value? So how would we do that? We just write an array and put the start value inside. Okay. Now we can create an else. And here we can include now our inclusive array recursive recursion. So to do that, what we can do is we can create a constant, and we can call it our array, and we can say that can equal the inclusive params recursive, okay, and then we can set it to the start value and the end value minus 1, right? Okay, and then after this we can do array dot push, and what do we want to bring into our array? Well, remember in our last recursive example, we were pushing, well, we were unshifting, but we were pushing before when it was incrementing our n, the number which was being subtracted each time. And this is what we want to be doing as well, right? So where is our n in this situation? The equivalent to our n value, right? Right, so we can actually pass our n value. And what's the final thing we should do for this function? Return the, we have to return the array, right? So let's go ahead and console.log. So I want you to console log you can pause the video, just console log what we did in the inclusive array param, 2 to 6, and do the same thing, only switch our string from iterative inclusive array solution to recursive inclusive array solution. So I'm just going to cheat and just bring this in, copy and paste that, and write recursive inclusive array solution. Okay, and we're bringing in the same parameters of 2 and 6, right? So when we go back into our dev tools, refresh, and there you have it. There's our final recursive inclusive array solution, where we get the same new array here that we're pushing our numbers 2, 3, 4, 5, and 6. Great job. If you've coded along the whole way through, and this is starting to make more sense to you, then congratulations, you are figuring out the fundamentals of recursion. And that's awesome. If they're still a bit confused, not a big deal. Just go back to the factorial sums, have a look through the video again, try to write out some recursion on your own. For another exercise, if you would like to continue practicing, instead of finding the factorial sum, try to do a factorial traditional multiplication. Try to make remember always to write out your iterative solutions before your recursive solutions. I mean, I know some people can write out recursion right away. It's a very small number. I would assume that most people out there, the most talented of such, are writing out their, you're going to write out an iterative solution first, and then recursion after that, for the most case, but I am not speaking on behalf of everybody. And yeah, that's it. I'm going to have this code posted up. I hope that you found some of this helpful for your understanding of what recursion is, and keep playing around with it, and leave me a message or leave a comment if you have any other good suggestions for exercises for recursion. All right, thank you very much.